Hello, I'm Natasha Pinol, the James Webb Space Telescope Program Communications Lead at NASA headquarters in Washington, D.C. Welcome to our Webb STEAM Day panel discussion. Before introducing our panelists, I'd like to turn it over to Chris Gunn, my co-host.
Thanks, Natasha. I'm Chris Gunn, joining as today's co-host for this panel talk. I'm a photographer at NASA's Goddard Space Flight Center, and where I've been documenting the James Webb Space Telescope for many years. And I'd like to thank the audience for listening in today. This is an amazing mission that will launch an Ariane 5 rocket from French Guiana in South America in December of this year. Webb will expand the scientific discoveries of NASA's outer space observatories like Hubble, Spitzer, and Chandra.
Webb is a revolutionary flagship mission that will unveil the mysteries of the early universe, from the first galaxies that were formed, and explore planets in our solar system, as well as distant worlds or exoplanets. Now I want to introduce our distinguished panelists who will give us an overview of the early design concepts for the Webb mission and how it evolved into what we see today. We're going to hear about how Webb was first designed on a paper napkin and see some of these concepts. Joining us is Dr. Eric Smith, James Webb Space Telescope Program Scientist and NASA Headquarters, Chief Scientist for the AstrophysicsDivision in the Science Mission Directorate. Chris?
And we're also going to hear from Dr. Garth Illingworth, professor at the University of California, Santa Cruz. His primary research interests are directed toward understanding when and how galaxies form. First, we're going to hear from Dr. Illingworth. Scientists and engineers had a lot of information to build on when designing the observatory, since other telescopes were designed and launched before it. Could you please give us a brief history about the early concept ideas for the mission and tell us about how the observatory's design started on a napkin?
Thank you, Chris. Thank you, Natasha. This is really such an exciting time. But doing a telescope like this is really like a Western saga. It's a great deal of plodding slowly and erratically across uncharted wilderness. So what I'm going to do here is take us back over 35 years ago when a small group of us first started to think about a huge new telescope. This was a time when scientists and engineers would sketch out concepts on paper and or wallboard. We were trying to decide what would take us beyond what Hubble could do, even many years before Hubble. So in 1985, that very early time, one of the first papers published by an exceptionally talented engineer, Pierre Boulez, was on what we came to call the Next Generation Space Telescope. This was done in 1985, 5 years before Hubble launched. Here is an artist's impression of that early design.
Can you just describe this artist sketch for us? Just tell us what's in this artist sketch.
Yeah, so here in this artist sketch is a rough visualization, something that we would have scratched out on a wallboard and then put into had an artist make into an image, and then also scratched out, as it were, a sketch of what the telescope might look like, just from our imagination. So that's what's in this concept from 1985 that was published. But the real effort then started in 1987 when a small group came together at the Space Telescope Science Institute. To give you a sense of the scale of these activities when we're actually doing a big telescope, here is the folks in 1987 that were all working on Hubble at Space Telescope Science Institute. Similar large numbers of people were working at NASA and in industry also on the telescope. But there was an opportunity then to work on something a little different, and that came up, and that's the result of a very small group out of this large number of people working on Hubble.
Dr. Illingworth, so who are we seeing in these photographs? And this is at the Space Telescope Science Institute in Baltimore, Maryland, right?
Yes, that is correct. So it's at the Space Telescope Institute. The person on the left there in the dark gray, in the gray suit, is actually the director, Riccardo Giacconi, who subsequently later got a Nobel Prize for his work on X-ray astronomy from space telescopes. And then he was the person who came into his office one day. He came in early one morning and looked at me and said, "You need to work on the next big telescope." I'm the person there with the second from the right, on that lower photograph with the red hair, unlike now. And so I thought about this, and I said, "Whoa, dear Ricardo, we're actually doing a huge amount of work on Hubble. Actually, trying to do work on another telescope just seems like a step too far." And he said, "Trust me, you guys have got to do this because it takes a long time." And so Peter Stockman, who's the guy there in the blue blazer, and Pierre Belly in his office to the right, the three of us basically formed a little core group that we started to work on the next generation space telescope. And so one of the things that played a role in our thinking and the discussions that we had with many other people at NASA and at the Institute was, what is the science this would do? Well, one of the things that was being discussed at that time was searching for planets like the Earth. We didn't know that planets existed around other stars, but we thought that it was very likely, many folks in the community thought that Earth-like planets were probably out there, but we would need an extraordinary telescope to see them and to find them. The other aspect that was also part of our thinking was looking for early galaxies. We were interested in seeing how the birth of galaxies, the galaxies that grew into the wonderful galaxies of today, like our Milky Way, like Andromeda. But overriding this in many ways was this feeling that if you put an extraordinarily powerful telescope out there, one that was maybe 100, 1,000 times more powerful than Hubble was going to be, we would just be exploring the unknown. We would be going into science, into the universe in ways that we could not conceive of. And so I put a big question mark for those amazing discoveries that a telescope would actually make when doing its work out with the capabilities that the next generation space telescope would have.
So Dr. Illingworth, just to give our audience a context, the Hubble Space Telescope launched in 1990. Planning for the next generation space telescope began in the late 80s, around 1989, you're saying?
Yes, so that was when we were spending our time doing the work on this new concept telescope. But one of the things that we realized very quickly was that we needed to involve the broad community, the engineering expertise, the scientists who are out there thinking about the future, and the engineering expertise in NASA and in industry in particular. So we set up a workshop called the Next Generation Space Telescope Workshop with the support of NASA and Space Telescope Science Institute, and really sat down for a week and went through concepts, science, and at the end had a wonderful discussion about just what a telescope like this could do, and the enthusiasm in the audience was palatable, very obvious, and very strong. And so that sort of set the stage in an important way for moving forward. But another important aspect of how we do new projects is what the astronomers and NASA call the Decadal Survey. This is done through the National Academy, and it's a very thoughtful process where every 10 years we, as the astronomers, come together in groups of 100, 150, 200 people on different committees and think about the future and make recommendations. And we had a panel that was working on space telescopes, and it discussed and argued extensively over this and ultimately came up and recommended a 20-foot infrared, very cold telescope in space. It's like in the next generation space telescope. The concept was gaining credibility and more input was made, more refined. On the lower right, that a sketch of the telescope is more detailed than before. And we thought that this could be launched in 2009. This was not actually accepted to move forward right at that time. That came later. Eric will mention something about that, I expect. But this was an important step in the process. But along with this, at the same time, was an extensive activity that was funded by NASA out of NASA headquarters through JPL to really look at the technologies for a telescope like this. And the technologies are extraordinarily challenging. When we had this workshop and we again sat down with a group of capable, experienced people for a week and thought through what we would need to be able to launch a telescope like this, I think we were in awe of the challenges that we had taken on at that point. And so this is sort of an important step that made us realize that scientifically this was magnificent and it would be amazingly capable. But doing a huge infrared space telescope where we use the universe to cool it down near absolute zero, and with a huge mirror, we were hoping at that time for a 26-foot diameter mirror, and putting it far away from Earth, this was extremely challenging. And so the next steps you will hear from Eric about.
Thanks for this great presentation, Dr. Illingworth. Now we'll turn it over to Dr. Smith to learn more about the observatory's final design, how that came to be, and see some of the full photographs that Chris took of this extraordinary mission.
Well, thanks for kicking it off there, Natasha. I think I'm going to change up the analogy a little bit from what Dr. Illingworth was talking about in a saga, and I'm going to phrase it in terms of a dance. When the music leaves off in the early 90s, Dr. Illingworth was talking about the community. The astronomical community was very excited for this new possibility. But it took about a decade for the musicians to come together. Hubble had to fly, and it had to be repaired and start to return data. And with some of those repaired optics images, that allowed the community to really know what needed to do next. In other words, the musicians had formed the stage, but now it was time for the partners to decide how they would do this dance, who would lead, who would be a part of it. And so what typically has to happen then is that while a scientist knew they wanted to have this big telescope, to actually move it forward in the Decadal Survey that was to come in 2000, they had to present a very coherent case. And so while you had a few compelling questions that would drive your design, you wanted to make sure that it appealed to a broad scientific audience. So we wanted to make sure we had enough people to like the music, that they would join, and the way that the scientists do this is to get together in rooms and talk about it. And so in 1997, in this book that you see here, we had this little compendium of all the scientists who came together with more ideas of what they could do if they had a big telescope, like the one that Dr. Illingworth described. And so not only did you see their ideas for exploring deep in the universe, but they talked about looking at how stars would form within our own galaxy, what you could do with it in our own solar system. So this was the first step where there would be enough people interested in this to move it to the next stage in the Decadal Survey. Were there enough people interested in the dance? Well, there certainly are. But you can't just have scientists doing this. And indeed, we heard early on one of the motivators behind the telescope we used was Pierre Belli, and he was an engineer. And so you wanted to make sure that the engineers and the technologists who will ultimately make the things that your telescope is made of, that they're ready as well. And what they need to do is that next leap. And so a few years after that first meeting in 1997, we had a gathering of technologists and scientists to say, if we wanted to build an amazing machine to do that science that we talked about, then we have to have these instruments or these technologies. And so now the band is gathering its new instruments together. And if I can stretch the analogy even farther, once people begin to hear the music and they see the partners going to the floor, well, it turns out that everybody in the world wants to participate. And while I don't need folks to really read this slide in detail, once this amazing telescope was coming a bit into better focus, we knew there would be partnerships with European astronomers and Canadian astronomers. And the point of this chart is to say that some of their early proposals for how they would join in the dance, some were accepted and some were ultimately not carried out. But that's all a part of these early negotiation stages where you try to determine who's going to be doing what and on what timescales you're going to do it. And so once you have all the players together, then it's time to really start the formalities.
So, Dr. Smith, the Next Generation Space Telescope, as it was originally known, was renamed the James Webb Space Telescope in 2002, and construction then began on its instruments in 2002.
That's right. And the complicated flow chart you see in front of you here is now the formalism of NASA coming down on this science concept. Once it gets ratified by the national academies in a Decadal Survey, they say this is the important science that you need to be doing. Then it's time for NASA to formally bring people on who will build your science instruments, who will build the actual telescope itself. And so the steps now become very formal, whereas before the dance may have been a little chaotic. Now there is structure to this dance. And what you see in front of you here are just the steps that have to get followed to pick who is going to build your science instruments. And it was also at this time that the telescope, previously known as the Next Generation Space Telescope, got named after James Webb, who was the second NASA administrator. And so now it becomes even more real because it has a name. And then if I can go to this last chart, which is a graphic that's way too complicated to try to explain, but it depicts the full formality of the dance. This is the kind of chart that NASA will use along with its international partners to complete the dance. Before, it was very informal, and now it's a full-blown waltz with everyone moving exactly as they're supposed to, doing certain steps at certain times, so that in the end, you have the space telescope that the scientists dreamed about so many years ago. Chris?
Yeah, Dr. Smith, I really love the analogy of the dance. Now, new technologies were required along with a battery of tests at every stage of this development. Scientists and engineers, took time to ensure that each instrument would operate as it was supposed to in space. Can you just elaborate on that process?
Sure, that's a great question. In this chart here, we have these early ideas from the 90s, and to turn them into the reality you see on the bottom touches on that second book that we showed a picture of, where people came together and said, well, if I'm going to build a telescope like this, I'm going to need some lightweight structures, or I'm going to need some new kind of detectors. And those have to be invented before you can start actually building it. And in the case of the James Webb Space Telescope, there were 10 things that we had to invent before we could even begin to build the telescope. And those cartoons, if you will, that you see along the top, each of those had some of the components that would eventually need to be made to realize the picture you have on the bottom. One of the designs may have had a certain kind of cooling element for an instrument. Another one may have had a very lightweight structure to hold a mirror. And that complicated process of bringing together the science, the technologists, and yes, even the managers, means that those technologies get sorted out, and the best, or the marriage of those is what you ultimately see there on the bottom. And it's always gratifying, I know, for people like Dr. Illingworth to see that those things that were drawings at the top now become amazing room-filling telescopes, like the photograph that Chris took, by the way, that you see there on the bottom.
Thanks, Eric. That was a fantastic overview of the history of the telescope. Let's look at some photographs of what the telescope's final design looks like today. This is a photograph I made in a clean room that shows the telescope in its full glory, with its tennis court-sized sun shield deployed and the primary mirror standing above it. And in these next two images, you can see the primary mirror in different states. That first image there shows the lens cap of the telescope being removed before launch. So launch is later this year, but we remove it a lot earlier than that. And in that second image, that's an image of the secondary mirror support structure deployed above the primary mirror, if you will, but it's on its side because they had to offload gravity's effect. So this is the kind of thing I get to see every day in the clean room, this design, this modern design of the telescope. But I've really enjoyed seeing a lot of the historical images that you and Dr. Illingworth shared with us.
Chris, those are amazing images. Thank you so much for sharing those. Well, that's all the time we have for today. I want to thank our panelists for a great conversation about Webb's design history and my co-host. We are very excited about Webb's upcoming launch in December, and we hope you enjoy today's session. For more information about the mission, see the website links on the screen and visit the interactive platform during the break. Thank you. Chris?
And definitely enjoy the rest of today's program and ask a question in the chat using the hashtag NASAWeb, and we'll get back to you. And if you're interested in design, check out the Webb Origami Design Challenge during the 10th annual NASA Space Apps Day on October 2nd. That's there's a link there that you can click to get to that. We also have an arts initiative and using the hashtag JWST Art. Thank you.
Thank you.